Hi there, my name is Ralph, and today we are doing longest palindromic subsequence. Given a string S, find the longest palindromic subsequence's length in S. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. Okay, that makes sense. Subsequence is different from a substring, okay, just to keep in mind. Example 1, S equal to B, 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 A, B. And output is 4 because longest palindromic subsequence is B, 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 B. That means we deleted A. Okay. All right, so just by looking at it, we can tell that this problem can be solved by dynamic programming. And so before we go into our code, I will explain to you how we will use dynamic programming in this scenario. So we have created here a 2D array. Rows here will be represented by I. The columns will be represented by J. So you might be wondering, why do I have a 2D array of size 5 by 5 already? Don't count the headings, so it's basically 5 by 5. The reason why is because I'm going to use the first example, which is the BBBAB. So I'm going to put that here. And so, as I mentioned, rows will be represented by I, J will be represented by, the column will be represented by J. Then I also put the length here because we would have to go through each of the length and determine if we can possibly form a palindromic with those given lengths, right? And so for the first one, which is length 1, right? It's basically saying, is each character a palindrome, which it is. So we would put 1 diagonally here, right? Anything below, it's also good to know that anything below this diagonal will just be 0 because we will not be using them. Okay, so now that we're done with length 1, let's deal with length 2. So now, what would be our routine in solving the rest of the problem? So here's going to be our routine. First is, if the character at start, which is the I, if it's equal to the character at the end, which is the character at J, index J, what we want to do is trim the end, trim the start, trim the end, and add 2 to the current spot. What do I mean by that? So the current spot that we're solving right now is this one, right? And so it says, if the character at start, this point has an I equal to 0, meaning this character right here, and if it's equal to the character at the end, J has a value of 1, this value right here, rather. It's basically saying, are these two characters the same? If they're the same, I want you to trim the start and the end. So trim it, trim. Now we're left with an empty string. It says here, add 2 to the current spot. So empty string, which is basically just 0, and we want to add 2 to it. Makes sense, right? So it will be the same thing for this scenario since these two are the same, right? We're checking length 2. So we check this, we're going to check this, we're going to check this, we're going to check this. So what about in this spot? Well, we have our second routine for that. It's basically saying that if the character at the start, which is, we're checking at this point, index I is equal to 2, meaning this one. If b is not equal to a, what do? We say get the maximum between the left sub and the right sub. What is left sub? Left sub means we have to trim the end. So given this substring, we want to trim the end. Trim. So now we're left with a b, which is basically just this value right here. Right? What about right sub? We trim the start. So given this substring, we trim this part. So now we're left with a, which is just this value. So basically, routine number 2 means that we're just getting the maximum between these two values from the current spot, right? So with that, since they're the same value, just put 1. And same goes with this one. And so now let's deal with length 3. All right, so now we're checking length 3 and dealing with this, and this substring. Okay, so length 3, this is the current spot. We're checking this and this. Since they're the same, what do? Routine number 1, we trim the start, we trim the end, we're left with this, which is this value right here. We add 2 to that. Okay, so now we're checking this substring right here. And we say B and A are not the same. So what do? We get the maximum, right? How do we get the maximum? We said we compare this value right here and this value right here. The one on the left and the one on the bottom. 2 is greater than 1, so we would put 2 in here. Same goes for this. Since B and B are the same, we just add 2 to this value, which is going to be 3. And length 4, same thing. We are comparing this substring and this substring. Now we're left with the topmost right corner spot. So now we're left with length 5. So let's do length 5. Sorry about that. That looks ugly. There we go. Now we're left with this spot. This is basically represents the whole string in itself, in its entirety. We're checking the start and the end character. They're the same. What does that mean? We just have to trim it and take this string into consideration. What is the longest palindromic subsequence that exists in this string? Well, there exists 2. So then say we just add 2 to that. So it's 4. And that's pretty much how the algorithm will work. So now let's put that into code. Okay, so first we have to set up our structure. We have an integer array, 2D array. So we say array, new int, and we put the sizes of that array here. I'll create a separate variable just because I know that I will be using length many times, and so I'd rather have it just saving an integer rather than calling the actual string. And again, you can just put s length here if you want to. So that's just my way of doing things. It's now the base case. As you remember, we filled up the diagonals with 1s, and so that's exactly what we're going to do here. So now we did that, And now we have to fill the diagonals. How do we do that? The rows will be the same thing as the columns and fill it up with ones. That's how I do it. And so now, in this part, we have to take care of filling up the rest of the 2D array given the length 2 to 5, or 2 to whatever the length of the string is. So we say for loop integer, take note, we start at 2. We don't start with 1 because 1's already filled up. And we do it until we hit we do it until we reach length plus. Actually, I think it would be better if we use current length, so it's much more understandable. So the current length that we're doing has to be equal, less than or equal to the current length, to the length of the string, and yeah. So what if we're traversing all of the lengths? We also need to traverse the actual 2D array, and for each specific length, some of them have more than one subsequence. And so we're going to have to create another for loop that will take care of just that, right? Say here, this will take care of the column, right? Per length, this one. And here, we'll take care of the j. The current I plus the current length minus 1. So let me explain what happens here. So we always want to start with whatever I is. I will represent the start character, right? And I want you to go until s length of the string, minus the current length plus 1. Basically, what this condition does is that it enables us to traverse the string with different start character without going beyond the bounds, right? The plus 1 here is just to take care of the 0 index, because we start with 0 index, right? And the j here is exactly just similar to that. It just represents the column. And so now we do here the two routines that we have. So we say if the character at the start, which can be represented by s char at I, that's the start character, remember? If it's equal to the character at the end, represented by j, we do something. If it's not, we do something else. Okay. So if it's the same, what exactly do we do? Well, the current spot, right? So if it's the same, we said that we want to add 2 to the current spot. Actually, it's not adding to the current spot, it's adding to the bottom left of it, right? So array plus 2. How do we find that value? Well, we decrease I, we decrease j, right? Well, actually, we didn't decrease I, we incremented. So again, to get to that value, we increment I, we decrement j, and we just add 2 to it. Perfect. But what about if it's an else? Well, we want to get the maximum. To get the maximum, we do this between two values. What are those two values? Right. So the first one is left sub. We trim the end. So we would leave our row the same. We would trim the end. Perfect. And the right sub, we trim the start. Then we have to increment it and leave the J alone. So we get the maximum of that and just return it to the current spot. Perfect. So now this whole thing will take care of filling up the rest of our 2D array. Fill up 2D array. Given the conditions that we have. And now we just have to return our answer. And our answer can be found in the topmost right spot of our 2D array. And that will be our row 0. And that will be at the length minus 1 column. And we just have to return it. Okay, yeah, so now before we run some tests, let's just go over the whole code again. So first, we establish the structures that we're going to use. We set up the 2D array as such, and I just created an integer just to save the length of the string, so we don't have to call it over and over. The base case, we filled up the diagonals with 1s, as I explained. Each character of the string should be considered as a palindrome, hence y. And then at this part, we basically filling up the 2D array given the routines that we have. In the routines, we say if the character at the start is equal to the character at the end, we add 2 to, we trim the start, we trim the end, and we add 2 to whatever is left on the inside, right? Else, if it's not the same, we get the maximum between left sub and right sub, as I explained. Lastly, we just have to return that value. So let's run some tests. Good. Let's run another. CVP. Good. I think this should be good. There we go. All right. Thank you guys for listening.